Hey everyone. Today we're going to be talking about the method of substitution, also known as U-substitution. The first two questions are questions you should be able to do without knowing U-substitution, so give them a shot. So the first one here is an antiderivative of a higher order function. So remember, add 1 to the exponent, divide by the new exponent, and divide by the derivative of the inside bracket. Next one. When you try the next one, you'll notice that what's in the denominator is to the exponent 1, so this is ln. And when you divide by the derivative of the denominator, you get 1 over 6 ln 6x plus 4. Make sure that you have absolute value bars around that bracket and a plus c at the end. Okay, so the point of U-substitution, or the method of substitution, is basically when you get a complicated looking question to make it a lot easier to work with. So at any point when you have a function times a function that you're integrating, so a product rule, or a function over a function, let's say a quotient rule, remember I said in class that there is no such thing as the opposite of a product rule or the opposite of a quotient rule. So as soon as you see that, that's sort of your hint that you want to try substituting. When you choose your substitution, you always want to pick the more difficult, quote unquote, the more difficult function. So in this case, my u, or the thing that I'm substituting for, will be 3x squared minus 2. So now that I've set my u to 3x squared minus 2, I want to take the derivative of both sides. When I take the derivative of u, I get du. And when I take the derivative of 3x squared minus 2, I get 6x dx, because I'm taking the derivative of that side with respect to x. My last step is that I want to rearrange for dx. So I want to say dx here is equal to du divided by 6x. So step 1, create a u function. Step 2, take the derivative of both sides. So the derivative of u is du, and the derivative of the other side is the derivative with respect to x, so dx. Step 3 is rearrange for dx. Now, what you want to do is substitute everything into the equation here. This is what you get. So you'll notice right now that the x stays. The 3x squared minus 2 we said was u, so that becomes u, and that's to the 7. And we said that dx was equal to this whole thing over here, so that's what I have over here. Well, the entire point of substitution is to have all of it with respect to u. So notice here I'm able to cancel out this x here and this x here, leaving me with the following. The integral of 1 over 6 u to the 7 du. Well, that's awesome. I now only have u's to deal with. This question becomes a really, really simple power rule question. So basically, I add 1 to the exponent, I get u to the 8, and I divide by that new exponent, so 6 times 8 is 48, and I have my plus c. But I still have to go back and substitute in for the original function. So my last step is 1 over 48 and then 3x squared. I think it was, sorry, just checking really quickly, minus 2 to the 8 and plus c. So again, let's refresh. Step 1. Make the more difficult, quote-unquote, function u. Take the derivative of both sides, rearrange for dx, substitute everything into the equation, cancel out any x's that there are. Notice you'll get an equation with just u's. If you don't get an equation with just u's in it, you've chosen the wrong thing to substitute in for. That's a really awesome hint right there. And then take the antiderivative and substitute back in with the original function. Give it a try for the next question. So looking at this next question, decide what u is going to be. Hopefully, you decide that the more difficult function here is ln 3x. So when you take the derivative, you get du is equal to 1 over 3x times the derivative, which is 3, so you get 3 over 3x dx, which I can simplify to 1 over x dx. Step 3, isolate for dx, so dx here is equal to x du. Step 4, sub everything in. Well, I have the integral of u over x, and then dx was x du. Awesome. I'm able to cancel out the x's, that's pretty good, which leaves me with the integral of u du. When I take that integral, I get a half u squared plus c, and last step is I substitute back in. So I get a half ln 3x, I can put that in brackets, squared plus c. So again, I'm following the steps. I substitute in for u, I take the derivative, I isolate for dx, I sub in, I should be able to cancel out some stuff, and I get to a point where I can take a really nice antiderivative. Give the next one a shot. So again, decide which is going to be the more difficult function. Here, probably you're going to say u is equal to 2 minus 3 tan x. Another awesome hint when you're trying to figure out the more difficult function is if when you take the derivative, like I do here, I get du is equal to minus 3 secant squared x. When I do that, hopefully when I get this awesome derivative, it's the thing in the other bracket that I'm going to be canceling out. And I forgot the little dx here. So when I rearrange, I get dx is equal to du over minus 3 secant squared x. Now I substitute everything in like I want to, so I get u to the 4 secant squared x is already there. I'm subbing in du over negative 3 secant squared x. So far so good. Cancel, cancel. Looks great. I'm left with negative a third, the integral of negative a third u to the 4 du. So I just want to finish up the question here by taking the integral. And when I do that, I get negative 1 over 15 u to the 5 plus c. And I want to substitute back in, and what I want to substitute in for is 2 minus 3 tan x. So last step is minus 1 over 15, 2 minus 3 tan x to the 5, and plus c. Okay, so this one's a little bit more challenging, and the reason that it's a little bit more challenging is that we have this exponential function in it. And remember, when you take the derivative or the integral of the exponential function, you'll get the exponential function in and of itself as well. So when deciding on the u here, give it a shot. See if it works for you. You may substitute in for the wrong thing and it won't cancel out properly. So if that happens to you, just be sure that maybe you're not picking the correct u that you're substituting in for. Give it a try. I encourage you to do that and then come back and see how you're doing with the question. Like I said, this one's definitely a tricky one. And the reason it is that you have to make u just the exponent there, x squared plus 6x. So that when you take the derivative of it, you get 2x plus 6. And there's your hint right there. Because if I take out a common factor of 2, I get that x plus 3 that's sitting out here out front. So definitely tricky, but still very doable. Because if you tried it and you took the derivative, you would have noticed that you weren't able to cancel anything out. Or if you did cancel stuff out, you got nothing left over, which was really hard to take the antiderivative of. So now that you're here at this stage, give the rest of the question a try. So when you substitute everything in, this is what you get. These cancel out. So you simply get the integral of a half e to the u du. And you know right away that the integral of a half e to the u is just a half e to the u plus c. And the last step, again, substitute in. So you get a half e to the x squared plus 6x and then plus c. So again, another exponential function here. you're definitely going to want to pick the u properly. Give this one a try. It's actually a little bit easier than the last one, and you should be able to do it without any difficulty. Okay, so most of you probably made u the root x, otherwise known as x to the half. I took my derivative and I simplified it so I could put the root x in the denominator, so it made it really, really easy for me to isolate for dx. So dx is equal to 2 root x du. So some of you probably did this. So some of you probably did e to the u over u, and then you substituted in 2 root x du. And you're sitting there thinking, oh my goodness, I have this root x that I can't get rid of because there's nothing to cancel out. Well, another option for you to say is e to the u over u 2 times u, because u is root x. And that would allow you to cancel this out and this out here. Some of you did this. Some of you probably did e to the u over root x, and then you did 2 root x du, and you were able to cancel out the root x's. So either way you saw it, you get to the same stage, so not to worry. Okay, and that same stage says the following. It says that I can do now the integral of 2e to the u du, which happens to just be 2e to the u 2e to the u plus c. And then last step is to substitute back in, so 2e to the root x plus c. So again, not super difficult, but there are a couple spots where you would have to do a little bit of extra thinking, particularly right here and right here, depending on the route that you chose, but it is a doable question. Okay, so last question of the day. Make sure that you decide what your u is going to be. Try taking the derivative, isolate for dx, and then substitute in. Everything should cancel out if you've chosen the right u. So give it a shot, and then come back and see if your work is correct. So when I try my u, I get to a point here where I just make u what's underneath the root sign. I take my derivative and I get this x squared, which I know I really want because I want to be able to cancel and cancel like this. When I'm able to do that, it makes taking my antiderivative a little bit easier. So for me, I find it a little bit easier if I change the root u in the denominator to u to the negative a half when I'm taking the antiderivative. So that means I add 1 to the exponent, which gets me to a half, and a third divided by a half becomes 2/3, and then I add c. Last step, I substitute everything back in, and I can make the to the half a square root symbol, or I can leave it as to the half. It doesn't really matter. I'd like to give you an opportunity to try the homework. The hardest part for some people is actually deciding what the u is going to be. Some people have difficulty figuring out whether or not they should use U-substitution. But remember, like I said at the beginning of the video, if a question involves two functions multiplied together, aka the product rule, or two functions divided by, also known as the quotient rule, that's pretty much your hint. Sometimes the IB will actually say use U-substitution, or they'll say let U be something. And so they'll actually tell you what that U is going to be. But some people find it hard to figure that out. So in the homework on the worksheet, part of the worksheet actually says decide what U is going to be and see if you're correct in figuring it out. So I hope this video is helpful. If you have any questions, please come in and see me. Take care, everyone. Bye.